In Lab 2, we'll explore the GNOME desktop environment running on the AM3517. We'll begin with Part A, where we'll start GNOME with a boot argument in U-boot. This is how the environment is typically started, and it's the simplest method. However, it does not give much insight into the interactions between the display manager and desktop environment, which is why we'll explore the topic further in Parts B through D. Lab 2A is fairly simple. As a matter of fact, the default behavior of the environment we're using is to boot in exactly this manner. We've been overriding that default behavior by inserting this keyword, the text keyword, in the boot arguments. If you look down here at the bottom of the page. So this final keyword text will, when you get to the portion of the boot procedure which would normally start the GNOME desktop and display it on the EVM's LCD, I'll show you when we get to that script. If it finds the keyword text in the boot arguments, then it will basically just bypass booting up the GNOME desktop. Now, the reason that we've been setting up the default behavior of our MMC card to bypass the GNOME desktop should hopefully become a little bit more apparent when we get to the later labs. Because what we're going to do in those later labs is we're going to configure the GNOME desktop to do a remote display. And so it's simpler to do that if we just boot without the GNOME desktop started up. We can configure it, and then when we manually start it ourselves, everything works as expected. So if we return to our terminal here and just start up the EVM board. We go through our normal boot procedure and we get to the portion of the U-boot which starts the countdown. Hit any key to stop the countdown. Now if we again print env the boot command, and you remember this is a very generic boot command. Basically the first thing it does is test the MMC card, and if the MMC card is present then it will attempt to run this MMC boot command. So if we print env MMC boot, then you can see it gives us a little message on the screen to indicate that it's booting from the multimedia card. It runs MMC args and then does a boot from memory, which it does a fat load off of the U image from partition 1 of the MMC card. Then that gets loaded into RAM and it boots directly from that portion of RAM memory. The part we're most concerned in is this MMC args. And if you take a look here, you can see it's sort of a standard setup for doing a Linux boot, except for at the very end we have this keyword text, which we had mentioned before. So all we're going to need to do for this lab is replicate this command, but removing the text keyword. So you can see that here. In order to overwrite this macro, we just use the set environment command. The macro name is mmcargs. And then you can see that we've put everything in mmcargs in a single quotes. What this does is it makes it a literal copy. So you see where we have console equals and then we're referencing the environment variable console. If we didn't put the single quotes around here, then when we did this set environment, it would take whatever the current setting of console is and put that into our mmcargs macro. So this is a typical procedure when you're writing a macro, because a lot of macros are going to reference other environment variables. If you just put the entire macro in a single quote like this, then you'll typically get the behavior that you're expecting. So we do that. Normally you would probably be used to doing a save env right now. I'll show you what happens if you try and do that. You see there's unknown command save environment. This isn't a bug. We actually recompiled the U-boot and took the save environment option out. The reason for this is save environment will save to the NAND flash on the board. And what we found is if people have been using the board and they had their own U-boot settings, then even though we were booting off the multimedia card, when we put our multimedia card in, everything would boot up through U-boot as expected, but then would pull the environment variables off of the board's local NAND flash, and so we got unpredictable behavior. What we did instead is took all the boot commands we wanted and built them into U-boot and recompiled U-boot so that those would be our default, and then removed the ability to do a save environment and override those default variables. Another method for doing the same thing is U-boot does support a boot script. So you can see here, if you look up a little higher in the terminal, that it attempts to run a macro called load boot script. If it does, then if it finds that boot script, it will run the boot script. The name is boot.scr, and we won't go through the details of that, but that's another method of working around the issue I just discussed, because the boot script will be stored locally on the MMC card in the first partition, and as a result, you can put whatever behavior you want in there and not worry about it getting affected by any settings that are stored in the NAND flash of the board. So again, we won't be able to do a save environment, but we have modified this macro in the RAM. So at this point we can just say run boot command. You'll see here, again, it looks for that boot.scr, which it doesn't find, so it'll go ahead and just use U-boot and the settings that we've specified. I'll go ahead and let you watch the trace as Linux boots up. Just in case you have any problems at home, it might be useful to see, you know, some of the trace that comes up with a successful run. And you can see here, everything has booted up. We get to the normal phase. Let me go ahead and show you what everything looks like over here on the AM3517 board. Here we see that the AM3517 Zoom kit has booted into the GNOME desktop. Notice that neither the Ethernet cable nor the USB cable are attached, so the board is booted in a completely standalone manner. If you do have a USB hub, keyboard, and mouse, then this is a good lab to go ahead and attach those. You'll notice, of course, as we move the mouse that the pointer moves on the screen. We can select Login, and then log in as root user. No password, and we'll actually now be logged in to GNOME running on the 3517. And even though we have all of that graphical display manager running on the board, we do still get this text terminal talking into the board as well. So we can log in as before as root with no password, and what I'll do is just show you the boot script that manages this. So the boot scripts in our setup are in the etc directory, and there's a couple of direct subdirectories that control this. So the first is the init.d or init directory, and you can see that there's quite a few scripts here in the init directory that control all of the different what they call daemon processes or servers that would be kicked off to run in the background at boot time. Not everything is necessarily a server, but this would be any type of initialization script, usually built around some Linux module. Now, just putting the script in this directory won't necessarily run it, but if we say list rc and then hit double tab, you can see that there's a number of directories, RC 0 through 6, and then RCS, which I think stands for system. These are the different run levels. By default, we're going to boot up in run level 5, which is everything that's on the RC5 directory. And let me do a LSA on RC5. And this is a little bit hard to read, but what I wanted to show you is you can see here that everything that's in the RC5 directory is a link into the init directory. So there's nothing here that's itself a script. Everything is just links referring back to that init.d. So now if I just do a normal list of the RC5, it's a little bit easier to read. You can see that not everything in that init directory is located here in RC5. So not everything in that init directory is going to be started up when we boot in run level 5. The other thing you'll see is that there's this S for startup and then a number after it, which indicates the order that everything's going to be run. So obviously, you know, if you're booting up an HTTP server, you need to have all of the networking configured before you start that up, typically. And so this is how you would tell the system what the order is that you want to start up everything in the init. Now you'll notice here that there's S99 GDM. So basically after everything else starts up, we're going to have the GDM. And if we do again a list LSA of RC5.D and S99 GDM, you see that this is a link back to init.d GDM. So if we do a more of a init.d GDM, you can take a look at the script. This is the script that starts up the GNOME Display Manager when we boot up the system. Most of this at the top is standard and you know, standard for kicking off daemon processes at boot time. Here the case 1 in start basically saying if we're attempting to start the GDM, and I'll go down to this part here, you know, so without trying to explain everything in the file, you do notice that after it does some basic setup to set up the GDM environment, it does this line right here. It does a grep, which is just a Linux search on proc command line. So when Linux boots, it stores the boot arguments that you passed it in proc command line. I'll show you that in a second. And what this command says is it says if the keyword text appears in the command line of the Linux boot, then echo not starting the GNOME Display Manager, so that just is going to send a message back to the terminal, and then it basically won't do anything. The next thing it'll do here is test this ELIF as else if. If it sees that GDM is not set up as the default display manager, then it also won't start it off. But finally, if it gets past those two tests, then it'll assume that you do in fact want to start up the GDM, and so it'll run this line. It'll echo that it's starting the GNOME Display Manager, so it'll echo that to the terminal. And then this is pretty standard for starting up daemon processes, especially using sys5, which is this whole initialization procedure that we're using. It runs a command called start stop daemon, and then it executes, and then this $ daemon is a variable that was set up at the top of the file that just it's actually set to the GDM command. So it will go ahead and kick off the GNOME Display Manager using this command right here. And here you can see that using the mouse we can explore the GNOME desktop as you would expect, the various pull-down windows, or even double-click on one of the partitions of our multimedia card and take a look at what's on there.